There are multiple organizations who provide limits for particle size classification. The numbers that we talked about earlier were the numbers provided by USCS, Unified Soil Classification System. So we talked about USCS earlier, where we define gravel as particles between 76.2 millimeters to 4.75 millimeters. So that's gravel. Sand is defined as particles between 4.75, so smaller than 4.75, but larger than 0.075 millimeters. And fines are defined as particles smaller than 0.075 millimeters, silt and clays. And then we look at the plasticity. So silt has low plasticity and clays have high plasticity. But based on the size, their particles smaller than 0.075 millimeters. This is the classification provided by Unified Soil Classification System, which is from U.S. Army Corps of Engineers. But there are other organizations providing different numbers. For example, we have MIT, Massachusetts Institute of Technology, and it has a different definition. Based on MIT, gravel is whatever that is larger than 2 millimeters. Sand is between 2 to 0.06 millimeters. Silt between 0.06 to 0.002 millimeters. So actually we have a size separation between silt and clay for MIT. And then clay is whatever that's smaller than 0.002 millimeters. That's the classification provided by MIT. USDA, US Department of Agriculture, also has grain size definition. So gravel is the same as MIT, but sand, the limit for sand is different, and also here silt. So sand is between 2 millimeters to 0.05 millimeters, and silt is between 0.05 millimeters to 0.002 millimeters. And then we also have the limits provided by AASHTO, American Association of State Highway and Transportation Officials. And again, different numbers. So we have 76.2 to 2 millimeters for gravel, 2 millimeters to 0.075 millimeters, sand, 0.075 to 0.002 millimeters, silt, and a smaller than 0.002 clay. So for these three, there is a size separation between silt and clay. For USCS, we call silt and clay fines, and then the separation is based on low or high plasticity. This slide shows the same thing. So we have the separation or the size definition based on MIT, USDA, AASHTO, and USCS. And again, USCS is the only one that has no separation, size separation between silt and clay, but the other three, so we have clay, silt, sand, and gravel. So again, when we have a gradation curve, we see these sections. So if we follow USCS, Unified Soil Classification System, these are the limits provided by USCS, then fines are particles smaller than 0.075 millimeters. So 0.56 here is 0.075 millimeters. And here we have sieve number 200. 0.075 is sieve number 200. Then sand is particles between 4.75 to 0.075. So here is 4.75 millimeters, and here is sieve number 4. So this is sieve number 200, and this is sieve number 4. And then gravel is defined as particles between 76.2, smaller than 76.2 millimeters, and larger than 4.75. So we have between 4.75 to 76.2 millimeters. And anything larger than 76.2 millimeters is referred to as cobbles or boulders. So now we want to calculate. What we are trying to calculate in this lecture is we have a soil sample. What is the percentage of gravel, sand, and fines? So we have a soil sample. We have gravel, we have sand, and we have silt and clay. We want to see what is the percentage of silt and clay, what is the percentage of sand, and what is the percentage of gravel. Again, our soil sample is made from particles with different sizes, and it's important that we know how much of each size we have in our soil sample. So that's what we want to do. We want to calculate the percentage of gravel, sand, and silt in our soil sample. Gravel, sand, and fines. For USCS, we will refer to it as fines. So, for example, gravel. Gravel is particles smaller than 76.2, larger than 4.75 millimeters. So in order to calculate gravel, the percentage of gravel, we need to look at percentage passing from these two sieves. So we're looking at 76.2. Here is 76.2 millimeters. And here is 4.75 millimeters. So you start from here, draw the line until you get to your gradation curve, and then draw the line to percent passing. We need to find percent passing from 76.2, and same thing here, percent passing. So you start from 4.75 millimeters, until you get to your gradation curve, and then from there draw the line to percent passing. The percentage of gravel is equal to percent passing from sieve 76.2, sieve that has an opening of 76.2 millimeters, minus percentage passing from a sieve with an opening of 4.75 millimeters. That's how we calculate gravel percentage. So 76.2 is 3 inches. Now we need to do the same thing for sand. Sand is particles between 4.75 to 0.075 millimeters. So we need to look at percentage passing from these two sizes. So you need to find 4.75 millimeters and 0.075 millimeters. We have the percentage passing from 4.75. You also need to find percentage passing from 0.075. Percent of sand in our soil sample is equal to percent of material passing through sieve number 4 that has an opening of, this is number 4. Number 4 has an opening of 4.75 millimeters minus percentage passing from sieve number 200, which has an opening of 0.075 millimeters. And this is 3 inch, which has an opening of 76.2 millimeters. And then finally, the percentage of fines. Fines are particles passing through or smaller than 0.075, which means materials passing through sieve number 200. So percentage passing, fines percentage is equal to percentage passing from number 200. That's So now we want to do the calculation for soil A that has this gradation curve. Percentage passing here from sieve 3 inch or the sieve that has an opening of 76.2 is 98%. Here is 98. And percent passing from sieve number 4 here is 62%. So percent of gravel is 98% minus 62%. Then for sand, we again need to look at 62% passing from number 4, and then percentage passing from number 200, sieve number 200, which is 8%. So percent of sand is 62% minus 8%. And fines is percent passing from sieve number 200, so it's just 8%. And if you add all of these together, you get 100%. So the soil that we have, 30% gravel, 54% sand, and 8% fines. Or we can say that it's 92% is coarse material and 8% is fines. So we can say that this is a coarse grained soil with 8% fines. You can try to do the calculation for soil B and soil C to practice. Now let's go over a couple of examples. Example number 1. This is very similar to question number 1 in soil homework. For a soil, suppose that D10 is 0.05 millimeters, D30 is 0.25 millimeters, and D60 is 0.5 millimeters. Calculate the uniformity coefficient and coefficient of curvature. Coefficient of curvature is D30 to the power of 2 divided by D10 times D60, and coefficient of uniformity is D60 divided by D10. So you just need to plug in the numbers and calculate coefficient of uniformity and coefficient of curvature. The following are the results of a sieve and hydrometer analysis. So again, if you remember, we said that for coarse grained soil, we need to do sieve analysis, and for fine grained soil, we need to do hydrometer tests. Then we combine them together and we have sieve size and percentage passing or percent finer for each sieve size. Then we need to calculate the percentage of gravel, sand, silt, and clay according to MIT system, USDA system, and AASHTO system. So the first thing that we need to do is to make our gradation curve in Excel. Here is the gradation curve. Now we're going to use the gradation curve and use this table to find numbers based on AASHTO, USDA, and MIT requirements, and then calculate percent of gravel, sand, silt, and clay in this soil sample. So based on MIT, we say that gravel is larger than 2 millimeters. We don't see 2 millimeters on the opening size curve, so we can say that everything pass through or everything is finer than 2 millimeters. So that's why we say that percent passing or percent finer than 2 millimeter is 100%. Again, if you look here, you see that everything 100%, smaller than 0.123445. So all the particles are smaller than 0.45 millimeters, which means that percent passing from 2 millimeters is 100%. Then we need to so we had percent passing from 2 millimeter is 100%. Percent passing again from 2 millimeter is 100%. We need to find percent passing from 0.06. This is 0.1 and this is 0.01. So 1, 2, 3, 4, 9, 8, 7. And we have percent passing from 0.06 millimeter as 82%. So sand is 100% minus 82%. That's sand. Gravel is 100 minus 100, which gives us 0. We don't have anything larger than 2 millimeters. Everything passed through 2 millimeters. Then we need to calculate silt. So we need to look at percent passing from 0.06. Percent passing from 0.06 was 82%. And also percent passing from 0.02. So now we look at 0.02. And percent passing from 0.02 is 11%. So silt is 82% minus 11%. And clay is particles smaller than 0.02, so it's equal to percent passing from 0.02, which is 11%. Now we want to do the same thing, but this time we want to look at USDA system. And USDA system, we have gravel defined as particles larger than 2 millimeters. Again, we don't have anything larger than 2 millimeters, so our gravel is 0%, 0%, 100 minus 100. Everything passed through the sieve that has opening of 2 millimeters. Sand is defined as particles between 2 to 0.05. So here we have 100% pass through sieve with an opening of 2 millimeter, and then we need to look at percentage passing from 0.05, which is 80%. So sand is 100 minus 80%. Silt, we need to look at percentage passing from sieve with an opening of 0.05 millimeters, which we have here 80%. And then 0.002. This is sand. Sorry, silt. So 80% and percent passing from this one is 11%. So silt is 80% minus 11%. And this was and this is how much fines we have, which is equal to percent passing from 0.002, so it's just 11%. Now we're going to do the same thing, but this time using AASHTO's numbers. Percent passing from 76.2 is 100%. Everything is smaller than 70.2, and here is also 100%. So gravel is 100 minus 100, which gives us 0%. We need to look at percentage passing from sieve with an opening of 2 millimeters and percentage passing from sieve with an opening of 0.075. So here we look at 0.075 and 2 millimeters is here. So this is sand, and this is what's important for us here. From 2 millimeters, everything passed through 0.075 millimeter. We have 90% of materials passing through. So sand is 100% minus 90%, which gives us 10%. For silt, we need to look at percentage passing from 0.075. So this is 90%. 90% of particles is smaller than 0.075. But then we also need to look at 0.002, which is 11%. Out of that 90%, 11% is smaller than 0.02. So silt is 90% minus 11%. And lastly, clay. So this is silt. And then clay is this area, which is equal to materials passing from sieve with an opening of 0.002. This is a quiz for yourself. You can practice by now doing the calculation for USCS system and also complete the optional extra credit quiz.